Okay, so today what we're going to talk about is we're going to talk about differential equations, and we're going to talk about separation of variables. If you guys remember when we did related rates, there was like a process that we followed. There's a very specific process we have to follow in order to solve our differential equations. Okay, and so there's 6 steps, and I'd like you to copy these down. I'll explain and we'll walk through how these steps actually work, what they mean. The first 3 rhyme, which is nice, but I do expect this order. The order is important, and the fact that you don't miss any of these steps is really important. On a lot of free responses, each of these steps is worth its own point. So just doing each of these things earns you a point, which is a lot of points for a single question. So the first one is separate. What that means is we're going to separate our variables. The second one is integrate. So we're going to integrate both sides of the equation. The third one is isolate. You can put in parentheses y. It's generally what we're isolating. Sometimes our equations are different. Sometimes we, instead of having like a dy over a dx, we have like a dp over a dt. You'll get in the habit, but in the first ones we're going to have all dy over dx's. So we're always going to isolate our y. Okay. Number 4 is initial conditions. So you're going to substitute in initial conditions. And what that will do is it will allow you to solve for C. So you're going to be able to find C. I know that this doesn't make a whole lot of sense right now. It's important you have this list, and we'll come back to this several times. Okay, and then once you have C, you can plug that back into the equation that you isolated in step 3, and that will give you your final answer. Okay, so your final answer is essentially substituting C back into the equation that you arrived at on number 3. So let's do an example. You don't need to write all these words down. I just copied this from an old AP test so that you can see like what the verbiage looks like. So, and again, I'm recording this, so I'll throw this up on YouTube. So you really don't need to write down all this stuff. It says, consider the differential equation dy over dx equals x minus 3 over y. Find the particular solution y equals f of x to the differential equation with the initial condition f of 1 equals negative 3. Okay. So essentially what we're doing here is we're trying to get back to the original equation, but we have variables on the right side that are mixed. So if I was trying to get back to the original equation, we know we would normally take an integral, but this is sort of like implicit differentiation where we had a mixture of variables. And so we can't take it with respect to x or with respect to y in the way that it's written because I've got both variables on the same side. So the first step we have to do is separate our variables. What that means is you want to get all the y's on the left side. Always put your y's on the left side, and you want to get all your x's on the right side. Now on this one, it's not too tricky to do that. I'm going to write down our equation really quick. Dy over dx equals x minus 3 over y. To get all my y's on the left side, and there's 2 things that have y in them. There's the dy and the y. Both of those have y's in them. So I need to get those on the same side. So I'm going to multiply that y up to the left side. So I'm going to get y dy on the left side. Make sure the dy is at the end. Dy times y is going to be a different thing. That dy is going to act like the period at the end of our sentence. So make sure the dy is at the end. So we get y dy. Now to get the dx over, I'm going to multiply the dx up to the x minus 3. So essentially what you're doing is kind of like cross multiplying for this one. That won't always be the case, but in this one it is. Okay, and we have x minus 3 in parentheses times that dx. This is worth 1 point on the AP test. A related rates multiple choice question is also worth 1 point. So if you can separate your variables on this kind of a question, you are getting a lot of points just for doing that. Okay, the next thing we're going to do, so we did step 1, we separated. We separated our variables, all the y's on the left, all the x's on the right. The next thing we're going to do is we're going to integrate, and we're going to integrate both sides of the equation. You do need to show that integration, but you don't need to show it like the symbol in a new step. I always just throw it in the same step that we separated. So I'm going to show my integration symbol. And what we're now going to do is we're going to integrate each side of that equation. Okay, this is where this gets a little bit tricky. So make sure you're focused here. We're integrating y dy, meaning we're integrating y to the first with respect to y. And then we're going to integrate x minus 3, that whole side, with respect to x. Okay, on the left side, we end up getting y squared over 2 Now, there's no bounds on these. So I'm going to get a plus C, but I'm going to get a plus C on both sides. So some guys are like, well, then don't the C's just cancel out? No, because they're not necessarily the same constant. So I'm going to write plus C1 over here. We're going to write this in a shorter, quicker way eventually, but I just want to explain this. So we get like one constant on the left side. So plus C1. And then that we're done with that first, the left side of the equation, that integral. Okay. Then we're going to integrate the right side. And so on the right side, we get x squared over 2 minus 3x. And then we also have a C over there. But again, it's not necessarily the same C. So we can't just put plus C and then think that they're going to cancel out. I had a C1 on the left. I'm going to have a C2 on the right. Okay. Now, normally what we're going to do is we're not going to include a C1 and a C2. We're just going to include one C altogether. Let's say C1 was like 3 and C2 was like 5, right? I could move that C1 over to that right side and I could subtract them. I could have C2 minus C1 and just get some new constant. So what we're going to do in general is we're going to skip this like step that I've shown in blue. And we're just going to have y squared over 2. We're going to leave the C off of the left side. And we're going to combine those into one C on the right side. So I'm going to get x cubed over 3. Oh, I'm sorry. Did I say x squared over 3? Why did no one correct me? You guys, call me out when I'm silly. X squared over 2 minus 3x plus C2. Sorry if that confused anyone. Please unmute if I ever make a silly mistake like that. It's early and I've barely had any coffee. So on the right side, we get x squared over 2 minus 3x and then plus C. Just C with no little subscript. Okay. Does that make sense how we're combining those C's? Like C2 is some number, C1 is some number. If I subtract C1 over to that right side, I just end up with some new constant. So we're just going to call that constant C. Are there any questions so far? Please ask a question if you have a question.
Would we need to write out that intermediary step with C1 and C2, or can we just go straight to, okay.
You're going to go straight to the yellow. I wanted to explain why we don't need a C on both sides, but in general, we're not going to show this step. We're going to skip right to the yellow step. Okay, so in general, that was a great question. Thank you, Mateo. We're not going to show that intermediate step. We're going to skip right to yellow. So you don't need a C on both sides. You do need a C specifically on the right side. So I don't want you to only include a C on the left side. And the reason for that is we're trying to isolate Y, right? So anything we can get away from that Y, we're going to get away from that Y. Great question. Okay, so we've done step 1, we've separated. We've done step 2, we've integrated. And when we integrate, make sure you recognize we are integrating both sides. Sometimes that step 2 is worth 2 separate points on the AP exam. Okay, sometimes that step 2 is worth 2 separate points, depending on the difficulty of each of those integrals. Sometimes it's worth 1 point, like did you integrate the whole thing? Now here's the deal. Here's where this really sucks. If you forget the plus C, we stop grading. So there's about 6 points possible. If you just forget plus C, you cannot get that second, third, fourth, fifth, or sixth point. All you can get is the separation of variables, just for forgetting plus C. It's really important you don't forget it. Okay. All right. From here, our next step is to isolate. So we're going to isolate Y. So to isolate Y, this is just some algebra stuff. We're going to multiply the 2 over. So when I multiply the 2 over, I get Y squared equals, well, 2 over 2 cancels. So I get X squared minus 3 times 2 is 6X. And now here's also where this gets confusing. I would also have a plus 2C, right? But 2 times a constant, it's still just a constant. So I am just going to leave that as plus some constant until we solve for it. As long as it's remaining a constant, we don't have to keep up with any sort of algebraic manipulations to that constant. Okay, so 2 times, like let's say the C was 5. 2 times 5 is still a constant, and we haven't figured out what that constant is yet. Okay, are there questions on that so far? Okay, so now we still haven't isolated Y. What we need to do now is we need to take a square root. And this is where it gets important. Okay, when I take a square root, when we have something squared, I get a plus and I get a minus. But for it to be a function, only one of those things will remain. And so our initial condition is going to define which one we choose. But when I first take that, I'm going to get the square root of everything on that right side. So x squared minus 6x plus c. But it could be the positive square root or the negative square root. It can't be both, so we're not going to have a final answer with a plus and minus. But we want to include that here because we want to remember we could have a plus square root or we could have a minus square root. Okay, so we're going to end up getting rid of one of those options depending on our initial condition. Okay, so now we've done step 1, we've done step 2, we've done step 3. Step 4 says initial conditions. And what that means is generally you're provided some information about x and y. Now it says f of 1 equals -3. We're working in terms of x and y. We're going to work in terms of x and y the whole time because this equation was in terms of x and y. Okay, so do not suddenly change anything to an f. I know it says y equals f of x. Leave everything in terms of x and y. Leave it in terms of what was given in that first dy over dx equation. Okay, so what this says, f of 1 equals -3, means when x equals 1, y equals -3. That's like such a silly little step to write out, but it really helps you not mix up which variable is which. Okay, so it's generally helpful if you're given f of something equals something to write x equals y equals. That way you know what you're plugging in. Okay, so when we plug in our initial conditions into that equation we did in white, we get -3 equals the square root of 1 squared minus 6 times 1 plus c. Now remember, I said we are not going to have both the plus and the minus, right? Right now we still have a plus or a minus as a possibility, but our initial condition tells us which one it has to be. So a square root all by itself, this portion is only going to produce a positive answer. Okay, just the square root by itself is only going to produce a positive answer. But what I know is based on that initial condition, I end up with -3, meaning it had to have been the negative square root. It couldn't have been the positive square root because I need my final answer to work with my initial condition. So that means we're going to get rid of this plus here. We're only going to keep the minus. And that will also be true on the equation we just did. So I'm going to get rid of the plus and the minus and just keep the minus. Are there questions on this so far? Okay, at this point, what we're going to do, it feels like we're going to kind of undo a bunch of stuff we just did. Essentially, we're going to undo both of those negatives, right? Because now we're trying to solve for c. So now we actually have to get c by itself. We're going to square both sides. So I'm going to square the 3. And I'm going to square the square root. So I get 9 is equal to 1 minus 6 plus c. So 9 is equal to -5 plus c. We're going to add 5 to both sides and we get c is equal to 14. Okay, so this gives me c equals 14. That's another point. So plugging in your initial conditions, solving for c, that's its own point. Okay, now final step that we have to do is we have to write our final answer, which essentially means substitute c into equation first from step 3, like the equation where we isolated y. That's really what we're doing for our final answer. Okay, so this was that equation right here where I isolated y, and we ended up picking the negative square root because of our initial condition being negative in this case. So now we're going to plug this in. We're not going to go back to that step and erase it. We're going to write a new answer so that all our work follows. And it's generally helpful to work vertically here. I ran out of room, but in general on your notebook paper, you're just going to work vertically the whole time. So we get y equals negative the square root of x squared minus 6x plus 14. And that's our final answer. That would have been the original equation given this initial condition with that dy dx. Okay, what questions do you guys have so far? Any questions on any of the
Do we
steps,
have
even if you're like,
to-
we already went over it? Sorry, go ahead.
Do we have to like erase the plus or minus in front of the square root, or can we just like rewrite it with
You can just rewrite it. I tend to go back and erase it or circle the one that's right, just so that I remember to use it correctly. Because some of you will like acknowledge it here, but then forget that you've done that. And when you go back to plug it in, you forget which one you picked, or you include both accidentally or whatever.
Right.
So I generally choose to like erase it or circle the one that's correct. Okay, not every answer is going to have a square root in it either. This one just happened to have where we were isolating y, we had to square root both sides. Okay, any other questions? Okay, we're going to move on to the next one.
This may be kind of arbitrary, but
yeah, go ahead.
Oh, no, I was just going to ask, like, would it ever ask us at the point where we're at now? Like, will it ever ask us to go back and solve for like C1 or C2?
Nope.
Or like
nope, because
X
we don't really
variable?
know what they are. C1 and C2, we know that they both could exist, but we have no ability to solve for each of them. We just have the ability to solve for whatever the total constant would be at the end. So yeah, no, they would never ask you that. Good question. Other questions? I'll give it like actually 30 seconds. If you have a question, if it's tickling your brain, ask. Okay, I'm going to move on. Okay, here's our next one. dy over dx equals 3x squared times y minus 1. I didn't write out all the words this time. I got lazy. It would be the same kind of words as question 1. And then it gives us our initial condition y of 0 equals 6. Find the particular solution. So find the particular solution just means find y equals. That's what it means every time it says that. Find that y equals using that initial condition. Okay, so step 1 is to separate your variables, meaning I want to get the y's on the left side and I want to get the x's on the right. Go ahead and see if you can do step 1. I'll be calling on someone in just a second. Let's go to Anthony. Anthony, so we have dy over dx equals 3x squared times y minus 1. How did you separate your variables?
I divided dy over, so I got y minus 1 over dy.
Hold on. One important step that I said before. Where do the y's have to go? On which side?
The same side. Or,
yeah, but specifically they need to go on the left side. So if you end up with a y minus 1 over a dy, you have moved this over here. We do not want that on the right side. And here's why, Anthony. We don't want something to be divided by dy. In order to have an integral, I need that dy up top. So that's why we're going to move this y minus 1 over to this left side. Has to work that way. Okay. Otherwise, we have a divide by dy, and we can't take an integral if we have a divide by dy. Okay. So instead of dividing over the dy, what will you do instead?
Divide y minus 1 over.
Perfect. So divide the y minus 1 over. So you can write that as 1 over y minus 1 dy or dy over y minus 1. Those are the same thing. Okay, so you could write it like this or dy over y minus 1. And then what would you do next?
Multiply dx over.
Perfect. So we get 3x squared times dx. So again, it's really important that the y's are on the left because you need the dy and the dx to be acting as multiplication. You can't have the dy or the dx on a denominator. So that's why we always keep our y's on the left, always keep our x's on the right. Okay. All right. This one is certainly a bit trickier. We started with something a little basic. We moved up quite a bit. Now what we need to do is we now need to integrate both sides of the equation. Now the right side of this equation is not too bad, right? So if I'm integrating the right side of this equation, I get 3x cubed over 3. So 3x cubed over 3. And then plus my c. Remember, my c is going to live on the right side. So I'm going to have a plus c over here. The left side, however, is a bit trickier. Eli, why is the left side a bit trickier to integrate?
Because it's a fraction.
It's a fraction, meaning if I was to do a derivative, I would need quotient rule. Therefore, to do an integral, I need what? Eli.
U sub,
I need U sub on this
the
one.
U substitution.
Yep, exactly right. So I need to do U substitution. So what we're going to do is we're going to do this U substitution off to the side. That's generally helpful so we don't get too confused. So I have the integral of 1 over y minus 1 dy. I'm writing it like totally off to the side so I can go ahead and do my U sub and solve, and then keep all of my nice separable differential equation work all in one. So the thing I'm going to choose for my U is the y minus 1. That whole thing is in the denominator. I get du is equal to dy. Okay, so that simplified quite a bit. Now my integral becomes 1 over u du. Does anyone know what the integral of 1 over u du is equal to?
The natural log of the absolute value of u.
Fantastic job, Charlie. Natural log of absolute value. Remember, the absolute value is essential. So we need natural log of absolute value of u. Now there's no bounds on this. So since there's no bounds, right, normally we would have a plus c, but we've included our plus c on the right side with our x. So we don't need to worry about the plus c, but the thing we do still need to do, since there's no bounds, is what? What do we have to do with u sub as our like final step when we have no bounds?
Substitute whatever we had in.
Exactly. We have to go back and substitute the u back in. So really we end up with ln of absolute value of y minus 1. Okay, again, that u sub being off to the side makes it way easier to keep your work organized. So I highly recommend doing that u sub off to the side just like we did. Okay, so over here on the left, we get ln of the absolute value of y minus 1 is equal to 3x cubed over 3. I don't know why that looks like it's so not lined up. ln of absolute value of y minus 1. Okay, 3 over 3 simplifies, so I'm going to go ahead and simplify that. 3 over 3 is just an x cubed. So this is what I have now, and I've integrated both sides. This is one where the integral is a bit harder, so they would probably give you points for each side of the integral. So like if you just got the x cubed plus c, you could get that point. And if you forgot something like ln, or even if you got the ln, if you have parentheses and not absolute value, we stop grading. We literally don't grade the rest of this. Okay, so it's really important that you remember that that absolute value has to go with that ln. Okay, so far we have separated our variables. We have integrated both sides of the equation. What step is next? Let's go to Conrad. What step is next?
Isolating y.
We have to isolate y. So y is kind of trapped. We've got y inside of an ln function. Does anyone know how we could possibly get rid of that ln?
Could you have like, I don't know how to say this, but have like both sides be exponents of e?
Correct. You're going to, the way that you say that is exponentiate both sides of the equation. So all this pre-calc knowledge is all coming back, right? In order to get rid of ln's, what we do is we exponentiate both sides from whatever that base is. And since our base is ln, right, that means log base e, we're going to exponentiate both sides from a base of e. This is a very, very common problem. It's very important you do this correctly. There's a very common mistake that my pre-calc guys make that I'm sure you guys made last year when you were doing similar problems. So look up at the screen. When you exponentiate both sides of the equation, you are exponentiating this entire side and this entire side. You are not exponentiating individual pieces. So it would be incorrect to have it like this. You are not doing e to the x cubed plus e to the c. That is not what's happening. What you are doing is e to the x cubed plus c. That whole thing is like the exponent of e right there. Okay, this is really important because we're going to do a step that's not super obvious. So that helps us. Fallon had that right. We're going to cancel out the e and the ln. So those now simplify. Now that the ln is gone, the absolute value goes away. Because the only reason we had absolute value was because of the ln. So now what we end up with on the left is y minus 1 equals e to the x cubed plus c with all of that stuff in that same exponent. Okay. Now here's another tricky step. This one is very tricky and not super obvious. I'm going to show just kind of a basic thing off to the side really quick. You guys know if I took x cubed times x squared, I don't know, I said that backwards, x squared times x cubed, I would end up with x to the 5th. Everybody is very, very comfortable with that. Is that true? Yes. What you're really doing there to get that 5 is you're really doing 2 plus 3. Everybody can see that, right? Now, if I have something like e to the x cubed plus c, what would that be equal to? So essentially I'm working backwards. So using the same logic, and I would write this down because this helps you make this connection on this super necessary step on a very common problem. Okay. Shirag, what would that be equal to using the same logic? If x squared times x cubed equals x to the 2 plus 3, what would e to the x cubed plus c be equal to?
Wouldn't it just be e to the x cubed times e to the c?
Correct. So not plus. If you remember a step ago, I said it's not the same as e to the cubed plus e to the c. It's not equal to that. What it's equal to is e cubed or e to the x
Wouldn't it be e to the
cubed.
x cubed?
Sorry. Thank you. E to the x cubed times e to the c. That's what this is equal to. Okay, so really it's the same as e to the x cubed times e to the c. The reason that this is helpful is kind of the same reason in that last step we could simplify a bunch because we ended up multiplying everything by 2, but we didn't end up writing a 2c because 2 times a constant is still a constant. So by that logic, e, which is a number, it's 2.7 something, e raised to a constant is also just a constant, meaning that this thing is equal to e to the x cubed times a c, right? It's just some constant. We haven't solved for it yet. So e raised to a constant is also just a constant. This is a very weird step to kind of understand. You will see this problem enough that you'll get practiced in how it works. Most common mistake I see is that students say plus c instead of times c. So I wanted to really go through and explain that logic here. Okay, so that helps us simplify our right side. That ends up getting us a constant times e to the x cubed on that right side. I like to put the constant in the front just to make it a little cleaner looking, but you could put the constant later. Are there any questions about this part? I expect there will be questions on this part, so please ask them. And this just makes it easier for us to solve and to get a final answer. And our final answer, we want it to look like what the College Board rubric looks like, or if we see a question like this in multiple choice, we want to be able to get there. That's why we're doing it this way. Okay. All right, so we still need to isolate y. The last thing we would do to isolate y would be to add that 1 to the other side. So if I add 1 to both sides, I get y equals on the left, c e to the x cubed plus 1. Okay, so I have now separated my variables, integrated both sides. On this one, because when we integrated, we got an ln of something, we had to exponentiate in order to continue to try to isolate y. We were able to recognize from our algebra 2 knowledge, since x squared times x cubed is x to the 2 plus 3, we could rewrite that e to the x cubed plus c is e to the x cubed times e to the c, which just became a new c. And then again, to isolate that y, we added 1 over. The next step is going to be to do what, Naman?
You try to find c.
We try to find c. How do we do that? What do we do? What was step 4?
Initial conditions.
We use our initial
Find the
conditions.
initial
So those are
conditions.
given up here. Y of 0 equals 6, right? That means x equals 0, y equals 6. Again, it's generally helpful just to take a second. Sorry, guys. I think I just dropped off. I apologize. I don't know why that happened. Okay. Did everybody hear that last step with Naman, that we're going to use our initial conditions? Yes? Yeah, okay. Sorry, I don't know what happened. My Zoom screen just totally disappeared. So we have x equals 0, y equals 6. We're going to plug those in. So we get 6 equals c e to the 0 plus 1. Now this looked like a very scary equation. We had ln's, we've had e's so far. Simplifies quite a bit, especially if you've written it this way in order to solve for c. So e to the 0, anything to the 0 is 1. So we end up getting 6 equals c plus 1. We can subtract the 1 and we get 5 is equal to c. Now our final step that we would do, George, would be what?
Well, we have to find the c, like you just did, and then.
Yep, so we found c, so what's our final step?
Okay. So after we find c, then we get the final answer by substituting c into the equation that we found in the third step.
Perfect. So here's the equation we
Which
found in that
was-
step 3. So that would be what?
So it's y equals 5e x to the power of x cubed plus 1.
Fantastic job. Excellent, excellent work. Okay, that would be our final equation. Okay, some of you are working a little bit ahead. That's great. If you can try to work a step ahead and see if you can get this right, just be prepared. You might need to erase or adjust. Okay, any questions on this? This is actually really common where you're going to see U sub, you're going to end up with maybe an ln. You're going to have complications where you have to exponentiate both sides. I wish this was like a super rare problem. It's not. It's very, very common, this type of problem. Any questions? On your quest, by the way, sometimes they call this constant capital A. On your quest, just be aware, sometimes they change it to a capital A. It's the same thing. It's just a constant. Go ahead, Ben.
Can you go over how you went from e to the x cubed plus c to c e x to the third?
Absolutely. So just to review this concept, what I have up here is I have x squared times x cubed, which we all know without having to think about too much is x to the 5th, because we know what we're actually doing there is we're actually adding those exponents together, right? If I have the same base, if I have a base of x and a base of x being multiplied, and those things are being multiplied here, then what I really do is I take this number and I add them together. Mostly we've only done it in that direction. Mostly you've ever been asked to find x to the 5th, right? Given x squared times x cubed. But the logic works in the reverse also. So if I have a base with things being added up top, I can go backwards. And what that would mean would be that same base, e, both times, would be multiplied, and each of those e's would have whatever is in between that addition. So x cubed plus c becomes e to the x cubed times e to the c. Does that make sense so far? Thumbs up. Yes? Okay. But we want to simplify that c as much as possible. So on that previous problem we did, we ended up multiplying both sides by 2 at this step right here. Like to go from the blue to the yellow, we multiplied both sides, or to go from the yellow to the green, we multiplied both sides by 2. And we left it as c because 2 times a constant is still a constant. So until we solve for it, we're just going to leave it as c, right? Like we had c1 and c2, we have 2c, all of that's just a constant until we actually plug in our initial conditions and solve. So we were using that same logic here because e is a constant. So a constant, like if it's like 3 raised to the 4th, that's also just still a number. There's no variables left in there. So that allowed me to rewrite this e to the c as just a c. And it is times because of that algebra 2 logic with x squared times x cubed. Okay. All right, we're going to move on to the next one. There's something else that sometimes you'll be asked to do, which is find the general solution. You'll notice there's a piece of information missing here. What's missing? Does anyone know what we're not given in this one?
The initial conditions.
We're not given initial conditions. So sometimes you won't be given an initial conditions. That means all you're doing is step 1, 2, and 3. Okay, so, and what that's called, you'll still get a y equals equation. It will just be the general solution. It won't be what's called the particular solution. The particular solution is what you find when you have initial conditions. So if it asks you for the general solution, all you're doing is step 1, 2, and 3. Okay, first thing we're going to do, separate our variables. Remember to leave the y's on the left and the x's on the right. Brian Luna, when you separate your variables, what do you get?
D of y d of y over y squared is equal to d of x over x.
Fantastic job. Excellent, excellent work. So we have dy over y squared equals dx over x. Okay, another way that you can write this, by the way, is 1 over y squared dy equals 1 over x dx. They're both fine. The only thing you can't do is write like the dy first and then write 1 over y squared. You have to have like 1 over y squared first, or you can have it as dy over y squared. Okay, excellent job. Next step we're going to do, Nathan, what would we do next?
Integrate.
We're going to integrate both sides. When we integrate the right side, we don't really need u sub because we would just end up setting u equals to x. So you would literally get the same equation, right? What is the integral of 1 over x, Nathan?
The natural log of the absolute value of x.
And then what else do I need on that right side?
Plus c.
Fantastic, plus c. Okay, now this is where guys get confused. They're like, well, 1 over x is ln. So probably 1 over y squared is also ln, like ln of y squared. Super common mistake. How do I integrate 1 over y squared, Dennis? What would I do to integrate 1 over y squared?
Isn't it 2 square root y?
So not quite. If you were to rewrite that as a power function, for example, what would that power function be, Dennis?
Negative, or y to the negative 2.
Y to the negative 2, right? So we only end up with ln when we have a y to the negative 1 because power rule fails. So y to the negative 2 is a different thing, right? So now when I integrate that, Dennis, remember I'm adding 1 to the exponent and then I'm dividing by that number. So we're starting with a negative 2. If I add 1 to that exponent, I get y to what power?
Negative 1.
Okay, over?
Negative 1.
Correct.
Negative
So
1.
you are confusing that with like to a 1/2, to a square root, or divided by a square root. So just be cautious of that, right? Negative 2 is not the same as like 1/2 or a square root, but it is a very common mistake. So we get this so far. What a messy equation we have. We are trying to isolate y, right? Y to the negative 1 really means 1 over y, right? So another way that I could write this, and divide by negative 1 is the same as times by negative 1. So divide by negative 1 is the same as times by negative 1, and y to the negative 1 is the same as 1 over y. So I could rewrite this as negative 1 over y is equal to ln of x with the absolute value plus c. Now we still have not isolated y. Does anyone know how we could isolate y in this case?
You could have y equals negative ln x plus c over or 1 over negative ln x plus c.
You are super, super close, Charlie.
Minus
so
c.
what you're essentially doing, or what you're thinking about doing, is like pretending that whole thing is over 1 and cross multiplying, right? I assume that's what you're trying to do. Or what you're doing is you're multiplying both sides by y. Here's an easier way to think about this. If I multiply both sides by y, and then I would have to divide both sides by this equation, right? So I'm really swapping out the y and that ln equation. What I end up getting is y equals, you still have a negative 1, which is the thing I didn't hear you say, Charlie, over that whole other side, ln of x plus c. So essentially what I did was I multiplied this guy up and I then divided this guy over. Okay, so I get y equals -1 over the ln of the absolute value of x plus c. All of that stuff in the denominator. Okay, that would be my general solution. So we'd be done with this part of the problem. Y equals -1 over ln of the absolute value of x plus c. Okay, now the next part of this question is going to ask us to find the particular solution given an initial condition. So again, we got y equals -1 over ln of absolute value of x plus c. And now it wants to help us find the particular solution given that initial condition. So that initial condition, go ahead and write that down, says that when x equals 1, y equals 1/3. So I get 1/3 is equal to -1 over ln of 1 plus c. See, all this pre-calc knowledge is coming back. You have to know what ln of 1 is. Again, I said this would definitely be on the no calculator section. Ln of 1 means e raised to what power is equal to 1. So that would be 0. So we get 1/3 is equal to -1 over 0 plus c. So just a c. And now we're trying to solve for c. Okay, so I could cross multiply to solve for c if I wanted to. I'd get c is equal to -1/3. And then I would be substituting that back into that black equation up here. So I would get y is equal to -1 over.
Wait.
Question?
Wait, Ms. Toshner, why wouldn't C be equal to just -3?
Oh, did I do that wrong? Cross multiply 3, c equals
I thought when you,
-3.
like, cross multiply,
Yes.
yeah.
Yep, thank you. Thank you. So we're at this step here, we cross multiply, we get c equals -3. Thank you. Sorry. Thanks, Gus. Okay, so now we're going to plug that in. We get y equals -1 over ln of the absolute value of x minus 3. And again, you can multiply the numerator and the denominator by a negative. Sometimes if this is multiple choice, they'll do that. And you'll end up getting like 1 over 3 minus ln of absolute value of x. Like all they did was factor out a negative from the top and the bottom and cancel. Both of those equations are fine. You don't really need to oversimplify. So this is the final answer. Okay, y equals -1 over ln of the absolute value of x minus 3. Questions on this problem? Again, if you ever see on your quest where it says find the general solution, or on an AP exam or in the practice we're going to do, all that means is do step 1, 2, and 3. Sometimes that will be all they ask. Sometimes in addition to that, they'll give you like a part B, and then they'll ask you to find the particular solution, which just means plug in your initial conditions, find C, and then substitute that back in. Okay, any questions anyone has on any of this stuff? This is hard. We got through 3 problems essentially today, right? So these take a while, and there's a lot of hard steps. You have to be very confident in all your integration stuff that you're doing. And so it's really important that you feel confident in all that stuff. As I said, it builds. And you'll notice we're calling back to a lot of like Algebra 2 pre-calc knowledge in order to solve these. So there are a lot of points, but they're not super, super easy, but you'll become very proficient in them. You have a quest that is on these that's due Sunday. I don't think there's very many questions, but you will notice that they take a while. So I'm giving you all class period tomorrow to work on this. So again, I encourage you to go find a place if you're on campus to work with others. If you're not on campus, maybe open up a FaceTime or a Zoom call with a buddy and just work on it at the same time. That way you have someone there to ask questions. You can always post questions to Classroom as well. One question is super going to trip you up. And I can't remember what number it is, but I wrote it on Canvas and I've already made a video for that question. Okay, so I think it's like question 14. It's towards the end. There's a question where essentially you need U sub on both sides of the equation. So when you get to that problem, check out that video if it's helpful. It's on my YouTube channel. I have it linked. Most guys find that helpful, but good luck. Next week, we're going to be actually working on some practice free response with this stuff. And then we're going to be adding to this and doing some new stuff. All right. Have a great day, guys. Have a good weekend. Be safe. Make good choices. I'll stay on if anybody has questions.
Thank you.
Thanks, y'all.
Miss Toshner,
Go ahead.
How do you say the exponentiate? How do you say that again?
You said it right, exponentiate.
But like
It's
How-
a, it's
like
a,
if
so
I were
instead
to
of saying like you're
exponentiate-
multiplying both sides or you're dividing both sides, what you're doing is you're exponentiating both sides. Like it's a verb.
by from E or by E
From a
or-
base of E, from a base
Okay.
of E. So
right.
exponentiating from a base of E or
Just
by a
making
base of
sure.
E. Exponentiating by E, you could just say that and everyone would know what you're talking about.
Okay. All right.
Okay.
Thank you.
Awesome. See ya.
Bye.